Hello everyone. After prime factorization, today's topic is HCF or GCF. HCF means highest common factor. GCF means greatest common factor. Both are same. Let's see what exactly it is. The highest common factor of given numbers is the greatest whole number, which is a factor of each of them. We have two methods for finding HCF. First, method of prime factorization. Second, HCF by Euclid's algorithm. In today's class, we are going to cover first method, HCF by prime factorization. Steps are: first step, find prime factors of each number separately. The next step, take greatest powers of common prime factors. Then in the last step, third step, multiply them and get the HCF. Let's move to exercise 3.5. First question, find the HCF by prime factorization, and the given numbers are 92 and 84. So we have to find HCF of 92 and 84. Now starting from first step is find prime factors of each number separately. So we have to find prime factors of 92 and 84. 92 and 84 separately. 92 is an even number, so 92 is divisible by 2, we will get 46. Again, it's an even number, we will get 23. And we know that 23 is a prime number, so this is my last factor, 23 and 1. Now for 84 is an even number, so we'll divide 84 by 2, we'll get 42, again even, 2, 21. Now we have to check for 21. 21 is an odd number, so the next prime number after 2, next prime number is 3. We have to check its divisibility by 3. 2 plus 1 is 3. 3 is a multiple or 3 is a number which is divisible by 3. So we can say that 21 is divisible by 3. Okay, directly we can write that 21 is divisible by 3. We will get 7. Now 7 is also a prime number, so we will get 1. Now in the second step, take greatest powers of common prime factors. So first of all, we have to write factors of 92 and 84. 2 to the power 2 into 23. These are factors of 92. Similarly for 84, 2 to the power of 2 into 3 into 7. So these are factors of 92 and 84. Now we have to take greatest powers of common prime factors. Greatest power of first number 2, greatest power of second common factor. Here only 2 is common number or common factor, so we have to take 2 to the power 2. So HCF of 92 and 84 is 2 to the power 2 is equals to 4. So 4 is the answer. This is final answer. Second question, given numbers are, no, we are going to solve third question. Question number 3, 21 and 106. 21 and 106. Again, we have to find prime factors of 21 and 106 separately. First number 21, second number 106. 21 is an odd number, and we know that 21 is divisible by 3. We will get 7. 7 is a prime number, so we will get 1. Next number 106. 106 is an even number, so we divide this number by 2. We will get half of 106 is 53, and 53 again is a prime number. It means 53 is divisible by 53 only. So after 2, next factor or next prime factor of this number is 53. We will get 1. It means for these two numbers we have, for 21 factors are 3 and 7, and for 106 2 into 53. Okay, these are factors. Now first step done. Second step, take greatest powers of common prime factors. Here factors of first number 3 and 7, factors of second number 2 and 53. Now where is common factor? 3 is a common factor, no. 2 is a common factor, no. 7, no. 53, no. So where is the common factor? We can also write 3 into 7 into 1 or 2 into 53 into 1 for these two numbers. So here only 1 is the common factor. So HCF of 21 and 106 is 1. 1 is the highest number, or 1 is the only number which is a factor of 21 and 106. Next question, question number 5. Given numbers are 58 and 70. Again we have to find prime factors of 58 and 70 separately. 58 and 70. Now 58 is an even number, so we will divide 58 by 2. We will get 58 by 2 is 29, and 29 is a prime number. It means 29 itself is a factor, and after 2 the next factor is 29. Okay, 70 is an even number. Dividing 70 by 2 we will get 35. Now for 35 we have to check its divisibility by 2. It's an odd number, so 35 is not divisible by 2. Next prime number is 3, so we have to check divisibility of 35 by 3. 3 plus 5 is 8. It is not a multiple of 3. It means 35 is not divisible by 3. So next prime number is 5. Yes, this number is divisible by 5 because for divisibility of 5, last digit must be 0 or 5. Okay, so 35 is a multiple of 5. We will divide 35 by 5, we will get 7. And 7 is again a prime number. It means this is the factor. This is last factor. We will get 1. Now writing factors of 58 and 70. 58 and 70. 2 into 29. 2 into 5 into 7. Okay. Now take greatest powers of common prime factors. Here only 2 is a common factor. After 2, 29, no. 5 and 7, no. So only 2 is the common factor, and we have to take greatest powers. Greatest power means we can write 2 to the power 1 in place of 2. So 2 to the power 1 is the greatest power, or simply HCF of these two numbers are 2 to the power 1 equals to 2. So 2 is the answer. HCF of 58 and 70 is 2. Next question number 7. Given numbers are 18, 36 and 27. So we have to find prime factors of 18, 36 and 27. 7. We start from 18. Okay, here 18 is an even number, so we have to divide 18 by 2 first. First prime number, 18 by 2 is 9. 9 is an odd number, not divisible by 2. Next prime number is 3. 9 is a multiple of 3, so we'll divide it by 3, we'll get 3, 3 and 1. So these are factors of 18. Next number 36 is an even number. Starting from 2, we'll get 18 in the step. Next step is same, or simply we have to repeat this. For 9, 3, we'll get 3, 3 and 1. And for 27 is an odd number, and we know that 27 is divisible by 3 also, so we'll start from 3. 27 by 3 is 9. 9 again is divisible by 3. 3 by 3 we'll get 1. So factors of 18, 36 and 27 are, for 18, 2 to the power 1, 2 or 2 to the power 1 into 3 to the power of 2. 36, 2 to the power of 2 into 3 to the power of 2, and 27 means 3 to the power of 3. Now we have to take greatest power of common factor. Here only 3 is a common factor, so HCF is greatest power of common factor. 3 to the power of 2, 3 to the power of 2, 3 to the power of 3. So greatest common number or greatest power of 3 is 2. So the answer is 3 to the power of 2 equals to 9. HCF is 9. Okay, next question. Question number 9. Given numbers are 104, 78 and 65. So you have to find prime factors of 104, 78 and 65. 104, 78 and 65. First number 104 is an even number, so we'll divide 104 by 2, we'll get 52. Half of 104 is 52. Again 52 is an even number. Again dividing 52 by 2, we'll get 26. Again even, so we'll divide 26 by 2. Next number is 13, and 13 is a prime number. We get 1. So these are factors of 104. For next number 78, it's an even number, so we'll divide 78 by 2. We'll get 78 by 2 is 39. Now 39 is an odd number. Odd number means it is not divisible by 2. So we have to go for next factor. Next factor means 3. 39 is divisible by 3. Yes. So we'll divide 39 by 3 and we'll get 13. Again 13 is a prime number, so we don't have to worry for other prime numbers. Just write 13 and this is the last step. Next number 65. 65 is an odd number, so it is not divisible by 2. Next prime number is 3. We'll check its divisibility by 3. Add 6 and 5. 6 plus 5 is 11. 11 is not a multiple of 3. It means 65 is not a multiple of 3. So we'll move to next prime number, that is 5. For 5, last digit of the given number must be 0 or 5. Here the last number is 5, so this number is divisible by 5. We'll divide 65 by 5 is 13. Again 13 is a prime number, so we'll divide 13 by 13. Now these are factors of 104, 78 and 65. So writing factors of 104, 78 and 65. We have 2 to the power 3 into 13. 2 to the power 3 into 13 for 104. 2 into 3 into 13. 2 into 3 into 13. And for 65, 5 into 13. So for all three numbers we have 13. 13 is common. And highest factor of 13 means 13 to the power 1. So HCF is 13. HCF of 104, 78 and 65 is 13. Now next question. Question number 10. No. We'll take 11. Numbers are 520, 550, 520, 550 and 7 to 8. 7 to 8. These are numbers. So we have to find factors of 520, 550 and 728 separately. 520 is an even number, so we'll divide 520 by 2. Answer is 520 by 2 is 260. Again, 260 is an even number. 2, we will get 130, again even number, by 2, 65 and 65. For 65, we know the factor is 5, we will get 13 and 1. So these are prime factors of 520. Next number, 550. Again this number is an even number, so we divide 550 by 2. Next number is 275. Latest number is 275. Now 275 is an odd number, so we'll check its divisibility by 3 first. 7 plus 5, 12. 12 plus 2 is 14, so 275 is not divisible by 3. Next prime number is 5. Yes, last digit is 5. So this number is divisible by 5. Now 275 by 5 is 55. We can check it. Again, 55 is divisible by 5. 55 by 5 is 11. 11 is a prime number. So these are factors of 550. Now 728 is the number. 728. So it's an even number. So we'll divide 728 by 2. Next number is 728 by 2 means 364. We'll get 364. Again this number is even number. So we'll divide 364 by 2. Half of 364, 182. Again even number by 2. 182 by 2 is half of 182 is 91. Now 91 is an odd number, so we have to check for its divisibility by 3. 9 plus 1 is 10. 10 means the number is not a multiple of 3, so it is not a multiple of 3. Okay. Next prime number is 5. Again for 5, last digit must be 0 or 5. Last digit is 1 here. So 91 is again not divisible by 5. Next number 7. Is it divisible by 7? So we have to check. 91 by 7. So 7. Remainder 2. 2, 1, 3, 13. Okay. 91 is divisible by 7. 7. 13. And we know that 13 is again a prime number. So 31 is my last factor. It means common factors are, so we have to write these factors for 520, 550 and 728. Factors are 2 to the power 3 into 5 into 13, 5 into 13. For 550, 2 into 5 to the power of 2 into 11. And for 728, 2 to the power of 3 into 7 into 13. Now, highest power of common factor. 2 is a common factor? Yes. And highest common factor, highest power of common factor or highest common factor is 2 to the power of 1 or 2. 5 is a common factor, no 7, no 11, 13, no. So HCF of these three numbers is 2 to the power 1 or 2. So 2 is the answer. Next question, question number 13. A boy wishes to cut as many pieces of ropes of equal length as he can from pieces that are 35 meter, 49 meter and 56 meter long. If he wants the pieces to be as long as possible and does not like to waste any rope, how long should each piece be? In this case, the maximum possible length of each piece is simply HCF of those three numbers of lengths of pieces. So first length is 35 meter, length of first piece, length of second piece 49 meter and length of third piece 56 meter. So simply maximum length or maximum length of piece is HCF of these three numbers. So we have to find HCF of all three numbers, 35, 49 and 56. So 35 is an odd number. So 35 is not divisible by 2. Next prime number is 3. 3 plus 5 is 8. 8 is again not a multiple of 3. So factor of 35 is 5. We'll divide 35 by 5. We'll get 7. 7 is a prime number. So 5 and 7. These two numbers are factors of 35. Next number 49 is an odd number. So we have to start from 3. Divisibility check for 3. 4 plus 9. 9 plus 4 is 13. 13 is not a multiple of 3. So this number is not divisible by 3. Next factor is 5. Again for 5, last digit must be 0 or 5. Here the last digit is 9. So this number is again not divisible by 5. Next prime number is 7. Yes, 49 is divisible by 7. We will get 7 and then 1. So factors are 7 and 7. Next number 56. 56 is an even number. So we'll start from 2. 56 by 2 is 28. Half of 56, 28. Again 28 is an even number. So we'll divide 28 by 2. We'll get 14. Again even. 14 by 2 is 7. Now 7 is a prime number. So these are factors. Now finding HCF, or first we'll write factors of these three numbers. 35, 5 into 7, 49, 7 into 7 and 56, 2 to the power of 3 into 7. So 7 is common number or 7 is common factor, and highest power of 7 is 1 for all three numbers. So HCF of 35, 49 and 56 is 7. So 7 is the answer. Now as per statement, he wants the pieces to be as long as possible and does not like to waste any rope. So by taking length of cut or maximum length of the rope equals to 7 meter, he will get 5 pieces of first rope, 7 pieces of second rope and 2 to the power 3 means 8 pieces of third rope. Also if we check, this practically length of first rope is 35 meter, length of second rope 49 meter, and length of third rope is 56 meters, and unit length of cut is 7 meters. So 7, again 7, 7, 7, 7, 7, 7, and 7. 1, 2, 3, 4, 5. 7 plus 7 plus 7 plus 7 plus 7, or 7 into 5 is 35. Yes, 0 wastage. 49, for 49 again, in terms of 7, we'll get 7 equal pieces. Again, wastage 0. And for 56, this is the length of the rope. So we'll get 8 pieces of 7 meter long unit ropes for 56 meter, 7 for second rope, and 5 for third rope. So by doing this, we can avoid wastage of ropes. So this is all from my side, from 3.5. Now I'll request you to please solve all the problems of this exercise, and if you have any doubt, any problem in finding HCF, please write your comments in the comment section. Thank you.